Hey, this is Steven from RC Engineering, and welcome back to my development series. This is video number 2 of the development series, and we're going to be working on the development of the thrust stand. We're going to continue doing that for a little bit longer until we can build it and do some testing. So I want to kind of mix up the development series here coming up. So what I'm thinking now is changing kind of the schedule. So each month we'll have 2 of the development series, and then we'll have 1 bench test, and then the very last week of the month is going to be a what's it called? Is going to be a rule of thumb series. So two developments like this, 30 minutes long. And then we'll have a test stand, generally off of what we built in that month, or have built previously, or basically built previously. So we could be doing a few weeks of running the test stand, or thrust stand, the brushed thrust stand, and doing stuff like that. And also other developments as they come along. If I increase my development speed, right? Okay, so luckily we have something that just came in yesterday that's really going to help us with what we're trying to do. I have a full set, well, partial full set. I'm missing 1 set of motors of all the brushed motors that we're going to test. So here I have 6x15s, I have 7x20s, and I got 8.5x20s. I do not have the 10.5 by, I'm sorry, I don't have the 10 millimeters by 20s, but these are all the ones I got. And I'll explain later in another video. I got these from FPV Warehouse. I'll do a video on these guys later after we review them and see if they're any good. So I have my calipers here to measure, to make sure that we get the right size that we need to. So we're looking at the thrust stand here. Okay. So we just went over kind of on the last video. I'm trying to remember, about a week ago at this point. It was the principles of how it works and stuff like that, and how both arms of the machine have to be equal distance away from each other from where they press on the scale and where the thrust is being applied. And since we only have a 5 inch by 5 inch maximum build volume on my Trinus 3D printer, which is sitting right here, we have to kind of design around that. So we're going to take a look at some different things that we're going to do on this guy, and how we're going to apply that. So let's go ahead and get started. So what I think I'm going to do is I'm just going to design it normally and then make sure it fits in this particular box here. So what I'm going to do is I'm going to go here and I'm going to turn all these into construction lines here, which basically means that they're not selected as objects. And then I'm going to go back in here, and I'm just going to have this one underneath just kind of be a shadow, just to kind of see where the outline is. And so I'm just going to leave that sketch on, and we're going to do some things on it. So let's go ahead and take a look. We're going to go in here, and we're going to go rectangle. So what we need is a pivot point, which preferably is just like a pin, or something. What I would really like to do is that needs to be very low resistance. I mean, it doesn't have to be very crazy low resistance. It just has to be slight, so pretty press fit, I guess you could say. Pretty snug would be okay, or if it was a bolt that would go through there, that's also fine. So it could be easily taken apart and bolted together, taken apart, and so we could get slight friction against those two, maybe with a nylon washer in between. So what I'm thinking is I'm thinking of a opening I'll go ahead and show you, and then we're going to have these be two separate parts. And I'll show you guys why in a second. So let's start another sketch, the second sketch. And this one is going to be the foot, which is the pivot point of where it's going to open. And so here we're going to look at how wide do we want this thing to be. This is only brushed, so let's say like 3/4 of an inch. Let's say that the bar itself, kind of like the square where both the pivots are going to come out of, is going to be about 3/4 of an inch tall. And then 3/4 of an inch. And then this one is 3/4 of an inch. So let's say that that is the stand itself. Now let's add something on the side here. Let's say that this one is like 3/8 of an inch. Yeah, let's do 3/8 of an inch. 3/8 of an inch by 0.75, 0.375 is 3/8 of an inch. There you go. And this one here is also 0.375 by 0.75. So there we go. So now what we're going to do is we're going to extrude this guy. I'm going to say 0.125 just to hold the sides together. And then we're going to pop the sketch back up so we could extrude this further. Now how tall is our piece going to be? So we want to add 0.125 plus some extra. So let's say if that's a 3/4 inch square, let's make this at least 1 inch tall. Okay, so there we go. Now we want to have a bolt hole in the side. And we'll do some research on this later, but let's look at one thing that I want to do. Project include. I'm going to project this bottom to make sure that I could use it to reference. So I could go here to here, and we're going to create an artificial center. And then we're going to select these two, make those construction lines, then put a point here. And then we're just going to do a placeholder hole cut. Let's go to hole. And we're going to do a 0.375. Oops, 0.375. Something like that. So that's a 3/8. That's a 3/8 bolt, which is pretty big. I think 1/4 inch is fine. Even smaller would be even okay, but through all, and then on the back side we put a nut, right? So there's our pivot point, and you just attach this to a table or whatever, or a sheet or something to keep it from moving. And then now we need this center point. So this is going to be a separate body. So you can rename this body if you want. Should be slow press. There we go. Just going to call that pivot. And we don't need that sketch. Okay, so now let's go ahead and look here at what we're going to do. Okay, so now one of the principles that we're going to go over is bending, and bending has to do a lot with what's called the it has to do a lot with the cross section, and it's called not the moment of inertia. Is it? Yeah, I think it's the moment of inertia. Let me see. Area moment of inertia. Okay, so it is. So I is area moment of inertia, and what that has to do with is the cross section. So we need to think about the worst case scenario on this, guys, is we do not want it to bend. So we need to make sure that whatever way, because if it bends, it's going to mess with how the torque is applied, because it's going to mess with the cross product too much, and it's going to cause us to get a lot of inconsistencies. So we could design this two ways. We could have it thick, which is really, a waste of material, or we could have it thin. So which way are we? Let's say that the force is being applied, let's say the force is being applied here, this way, which is the negative y direction. So this is the y-axis, as you see here. This is the x-axis. So let's say that the force is being applied down on the y-axis here. So are we going to have it this way, or are we going to have it this way, or are we going to have it this way, right? So this way, what will actually happen is the eye is smaller this direction than the eye the other direction. So when it's flipped the other direction. So the equation here is m equals EI, and m is the internal bending moment of the beam, which is a torque, and E is the Young's modulus of the material, which is the stiffness of the material, and I is the moment of inertia cross section. So basically what we need to do, the equation is here, is m, which is internal bending moment of the beam, E, which is Young's modulus, and I is the area moment of inertia. So we need to find, as you see here, I, the lower we get I, the lower the bend, and then this is the bending distance. And the higher we get the Young's modulus, the higher the I, the lower the bending distance. The higher the E, or the higher the stiffness, the lower the displacement distance as well. So by changing the cross section, being like this, for example, or the width, it will basically change everything. So let's take a look what we would look at. So here, I dA times d squared. Actually, you know what we can do? We could actually have this guy calculate for us, but yeah, let's do that. Okay, so first I'm going to try to do the way where it's tall on the top side. So let's say that this is 3/4 by, no, sorry, this is 3/4. Let's say this is 0.75 divided by 3, let's say, something like that. Okay, let's extrude this distance 4 inches. Now, let's see if it'll give me properties of the body. Moment of inertia at center of mass. So here 4.697, 4.555, and 0.177. So what you need to do is you need to have it applied on whichever axis. Right, so here the x is higher than the y, so 4.697 is higher than the y, which that's this here is higher than the y here. So basically, when we apply a load here, it will resist bending more than if we put a load here on this side. And moment of inertia, origins, center of mass. Interesting. And here, so basically what you do is you pick the axis that is being that's being bent along, and you use that moment of inertia of that axis to do that equation. And there's equations for each shape on how to do that. So here's a engineering toolbox 1. Square. Okay, so here's a solid rectangular cross section. The area moment of inertia for a rectangular cross section can be calculated as IXBH3 divided by 12, where B equals width and H equals height. So IY is equal to B3H divided by 12. Alright, so you could basically pick the lowest, but the idea is that you want the highest number there as possible, right? So in this case, this direction is the highest, so this is kind of how we want it, because we're going to apply a force here, and it's going to resist that force and resist bending. We're not worried if we're putting the force this way, we're not really worried about it bending left and right. Okay, so that's one portion there. Now we need to actually attach the next portion. So the next portion is going to be here. And what we need to have is we need to have a square that's 0.75 divided by 2. .75 by 0.75, like that. And then we need to extrude it downwards. And then this is going to be all one body. And this we need to extrude negative 0.75. And we need it to join. So now it's all one piece. So now this is that center point that's going to pivot. And we're going to find the exact center here and have it pivot in that section. Another thing that we're probably going to want to do is we're probably going to have to want one-sided rounded, but hopefully it'll hover slightly above the ground so it won't actually hit. But we'll do an assembly of this guy, I don't know, in this video, maybe the next one, to see if this guy is going to hit. And because assembly is very important in order to look at how things are going to function. Okay, and then the next one is we're going to draw another sketch on the front here, and we're going to draw another same size. It's going to be whatever this one was. It was 0.75 divided by 3 by 0.75, like that. And then we're going to extrude it a certain height. Let's do 3 inches for right now. But what we need to find out is how tall this one is. From here to here, it's 3.25. So here to here is going to be 3.25. So I need another quarter of an inch. Again, this is going to make it difficult to transport. So what we might, or to store, so what we might do is you might do a 45 here, up this way, and have it push down. That would actually be an ideal way of doing it. Okay, so now we got that guy, and this guy would definitely fit in there, so we could actually move it and see if it'll fit. Clearly fits easily. Now both pieces fit. Now this guy's there, this guy's there. Okay, so Now we're going to do a sketch on this guy. We're going to blow a hole in the center. And to put a hole for our screw hole. So let's go ahead and do this, and we're going to do a point. Oops. Going to do a point. Okay, and we're going to drill a hole. This is going to be a 1/4 inch hole through all. Cool. And now that's ready to go. Now we need a top cap and a bottom cap to press down on the scale itself. And so let's do that right now. And then we need a top cap for the motors itself. So let's go ahead and draw a rectangle. And then these are 0.75 by 0.75 divided by 3. Okay. And we're going to do an offset, which is O is a shortcut. And this is going to be, let's say, 1 inch. That's fine. Okay, so that's going to be one of our little pressing pieces. So let's go ahead and extrude this cap here. Actually, what I want it to do is I want it to have a small little cap here, and then this be kind of big coming off. So what I'm going to do is I'm going to extrude this 0.1, and then I'm going to re-show that sketch. And let's go ahead and extrude this about 1/4 inch. Or, well, let's do 3/8. Okay, so there's the cap, and then on the bottom we're gonna put a little pivot piece here. So let's go ahead and see, is it gonna find the center first? We'll draw a square here to find the center. And then let's do this 1/4 inch by 1/4 inch. Let's go ahead and stop that, and we're going to extrude this 1/4 inch down. But see, now you see a problem here is that this is not going to print correctly because it's hovering underneath. So what we need to do is we need to edit the sketch, and then I need to delete this constraint if we can get to it. Okay. It's pretty much there. Okay. So now let's go ahead and stop that. Okay, and there we go. There's our little stump. It's at the bottom. This guy slides onto the end there, and it's ready to go. Okay, so now let's do our little motor. So let's rotate to the top. Let's do our little our motor holder. Okay, so for the motor holder, we're going to do something similar to this guy, but instead of this piece, this is going to be open, kind of like that is on the top, and open all the way through, and we're just going to have a hole drilled in it. So let's do that again. So let's do a 0.75 divided by 3. And this one is 0.75. Then we're going to do an offset 1 inch, 0.1 inch. I'm going to stop that. We're going to extrude this 3/4 of an inch, 0.75. Sorry, 0.375. And then we're going to go here. Actually, Oh yeah, it should be okay. So now we're going to see how big this guy actually has to be to clear our motors. Okay, so we're going to have one for each. So this is 0.6 millimeters. Sorry, not 0.6, 6 millimeters. Plus, generally I go like 30 thou. 0.030. Just for clearance, because it's going to shrink, and so you need that to fit. So let's go ahead and stop that sketch. Now we're going to do an extrude all the way through. And there's our hole. And then what we could do here if we want, so we can put some text on top of this guy. We could say 6 millimeter. And then rotate this guy around. And then make this guy height 0.050. Just like that. And then we're going to stop that sketch. And then we're going to pop it up. No, 0.025. 10 thou. I think at least 50 thou. That looks very exaggerated. Point zero. I mean, theoretically speaking, compared to everything else, yeah, that's going to be pretty big, but... Or what I could do, actually what I like better, is let's cut it. Cut. And have this be like a 10 thou. 0.010. There we go. Okay. Got a few more minutes left. So let's do another rectangle. I think that's a little close to the other one. 0.75 and then 0.75 divided by 3. And then offset. That's 0.1. And then we're going to hit extrude. This one 0.375. And then we're going to put a motor in it. And this one is 7 millimeters. See, but now at this point it's barely even touching. But we'll have to change that on the next time. This is just kind of a just a little test run, I guess you could say. Okay, this one, I'm going to do sketch on top, do some text. I'm going to say 7 millimeters. And this one was 0.050. Stop sketch. I'm going to push this down. Can't remember what I made that one, but whatever. Okay, so we're pretty much out of time. Delete this one. We're gonna go on top. Sketch rectangle center point 0.75, 0.75 divided by 3. Offset 0.1. This one's probably gonna have to be bigger, but we're gonna make them all the same size, so we get kind of that iterative process going. It's going to be 8 millimeters plus 0.030. Stop sketch. Push extrude through. Cut through all. Okay. Put a sketch on top. Do text. Bang. This is 0.050. It's going to be 8.5 millimeters. Speaking of which, I don't know if I did the 8.5 millimeters, but I'll double check. After I extrude this guy down, I can't extrude it down much. It's going to be like that's 20 thou. I'll be okay. Okay. So I'm going to double check this hole here. Yeah, it's just barely through. Okay, so we have most of our parts here. Next video we're going to be refining these guys to get them exactly where we want them to be, and we're going to do some updating on them and get them to where they're perfect and do some optimization. We're going to do some stress training. We're going to do some stress testing of it. We're going to do some optimization of how things are located and weight and print time to make sure that we don't use so much material. And then we're going to print it, and we're going to do some testing on it. So hopefully you'll see those next week. Hopefully we get them done in the next 2 videos of next month. Because the next video you're going to see is a rule of thumb series. So this has been Steven from RC Engineering. If you like this video, please subscribe for more views like it on my channel. And also, if you want to check out some extra content that I will not be releasing on YouTube, go ahead and check out my Patreon. Link is in description for some extra free RC content. And I will see you guys in the next video. I'd like to thank you guys for watching. If you like this video, please subscribe for more videos like it. And I'll see you guys in the next video. Thanks for watching. Take it easy.